Hello, myself Mohammed PASHA and I am a faculty of science in Global Academy. Today I am here to explain one of the important chapter of 10th standard, that is metals and non-metal. First of all, please like, share and comment upon our videos and subscribe our channel, and don't forget to click on the bell icon to get the future notification of our videos. Hello students, today we are here to learn another one chapter of 10th standard, that is metals and non-metals. Already you have been learning in your lower classes, that is elements have been broadly classified into metals and non-metals. Before going to study about this chapter, first of all I will say you what do you mean by the word metal. Metal is a thing in which the electrons are being arranged in the order of 1, 2, 3. For example, if you write the electronic configuration of sodium, the electronic configuration will be 2, 8, 1. You are getting here 1 electron in the outermost shell. In the same manner, if you write the electronic configuration of magnesium, the electronic configuration will be 2, 8, 2. In the same manner, aluminium also 2, 8, 3. So here, as you write the electronic configuration, you are getting in the outermost shell as electronic configuration as 1, 2, 3. Hence, metals are those who have the electronic configuration, or in their outermost shell they have 1, 2, 3 electrons. Whereas the non-metals are those who have in their outermost shell as an electron in the manner of 4, 5, 6 or 7 also. Let's take one example. If you write the electronic configuration of carbon, the electronic configuration will be 2, 4. So here you are getting in the outermost shell 4. So non-metals are those who have the electronic configuration in the order of 4, 5, 6, 7. So let's go on through your syllabus. In the beginning, in your syllabus they are discussing the physical properties of metals and non-metals. First of all, we will learn about the physical properties of metals. Physical state, all the metals are solid in the nature except the mercury and the gallium that exist as liquid in the room temperature. Next, metals are hard except the lithium, potassium and the sodium. In your textbook, they maybe can ask one question here. Name the metals that can be cut with a knife. The metals that can be cut with a knife are lithium, potassium and sodium. So remember, whatever I have mentioned here in the bracket, it is all being appeared as a choose a correct answer or 1 mark short answer questions. So metals are solid except which metal? That is a mercury and a gallium that are liquid in the room temperature. And all the metals are hard except lithium and potassium and the sodium. They can be cut with a knife. They are very soft metals. Metals have metallic pressure, that is they have the characteristic shining property. And metals are malleable. You are all familiar in the 9th standard also. You have been learned the meaning of the word malleability and ductility. Malleability means that is metals can be beaten into the tin sheet. Whereas ductility, metals can be drawn into the wire. Here I will say you one point. Gold is the most ductile metal. You can make 2 km of wire of the gold in just 1 gram. So the most ductile metal is a gold. And along with that, another one extra point I will say you, that is a tungsten. You are all familiar with that. Tungsten you can ductile into an invisible wire. That much most malleable ductile also the tungsten. Next we move on to the next physical property. Metals have high melting point. That is a gallium and a cesium. They have the low melting point. They melt in the palm of your hand itself. That is a what you have the body temperature. Within that body temperature itself, this gallium and the cesium will melt down. So remember, all the metals they have the high melting point except gallium and cesium. Metals have high boiling point. You are all familiar in the lower class itself. You have learned the meaning of the word melting point and the boiling point. The temperature at which the liquid begin to boil. That is we consider that one as a boiling point. All the metals, they have high boiling point. Metals are good conductors of the heat. Best conductors are silver and the copper. Poor conductors are lead and mercury. This question also they have asked in your index question in your textbook. That is, name the metals who are the best conductors of the heat. That is silver and copper. Because of that only we use it in the vessels too. Poor conductors of heat are lead and mercury. In the same manner, the electrical conductivity, all the metals are good conductors of electricity. One of the best conductors of electricity are silver and the copper. So maximum in domestic electric circuit will prefer the copper because it is one of the best conductor of electricity. Let's move on to the last physical property of the metal. Metals are sonorous in the nature. There is a metals, if you tap them, they'll produce a characteristic sound. That character we consider as sonorous character. Okay, now let's move on to the next slide, which deals with the physical properties of non-metals. First of all, let's go through the physical state of the non-metals. All the non-metals are existing all three states of matter, that is namely solid, liquid and gases. Example, we have some solid non-metals as carbon, sulfur, phosphorus. Liquid non-metal as bromine. Gases we have oxygen, hydrogen and nitrogen. So remember, they'll ask choose a correct answer whatever the points I have quoted in the bracket. As an example, we can ask, give example for solid non-metal, give example for liquid non-metal, give example for gaseous non-metals. Non-metals are soft, but except the diamond, which is the hardest natural substance. But remember, diamond, it is an allotrope of the carbon and it is one of the hardest substance in the nature. Non-metals do not have the lustrous property, but except one of the non-metal we have, that is the iodine, which is iodine crystals have lustrous nature. Non-metals are not malleable. You are all familiar with the malleability and the ductility property, but the non-metals are non-malleable. Non-metals are non-ductile. We can't draw into the wires. Non-metals which are solid and liquid have the low melting points. As you know the meaning of the word melting point. Non-metals which are solid and liquid have low boiling points too. Non-metals are bad conductor of heat because in the case of the non-metals, electrons are not free to conduct the heat, hence they are the bad conductors of heat. In the same manner, non-metals are bad conductors of electricity, but except the graphite, which is a non-metal, but even though it will conduct the electricity. In the periodic classification of element, we have gone through a one term called as a metalloid. That is, a metalloid is nothing but an element which exhibit the property of both metal and non-metal. So here we can consider an example of the metalloid. It is a graphite. But even though it is a non-metal, but it is showing the property of the metal as a conductor of electricity. So let's move on to the chemical properties of the metals. So the last point, which is a concern with the physical properties, non-metals are not sonorous. Chemical properties of metal. Even this question can also be appear in your exam. Already in the practice paper and the preparatory discussion have been came. List the chemical difference between the metals and non-metals. Whereas previously whatever we have been learned as a physical difference, this question so many times it has been repeated in your exams. So the chemical properties are, first of all, we will discuss about reaction with the oxygen. Metals are react with oxygen to form corresponding metallic oxides. When the copper is heated, it combines with oxygen to form copper oxide. Then we can ask this equation also for 1 mark, how the copper react with the oxygen. When aluminium is heated, it combines to form the aluminium oxide. In the same manner, the different metals as a sodium, like a sodium, about that remember, Sodium, it reacts with oxygen to form sodium oxide, but suddenly this sodium oxide, as it reacted with the water, it is forming the basic oxide. It forming the basic oxide as a sodium hydroxide. From this point, we can clearly conclude that all the metals are basic in the nature. Did you get? All the metals are basic in the nature. Whereas in the same manner, potassium also, it will react with the oxygen to form the potassium oxide. As the potassium oxide is dissolved in water, it forms the corresponding potassium hydroxide, which is a basic in the nature. Some metallic oxide, they show the property of both acidic and the basic properties. Both the properties are exhibited by some metallic oxide. Such metallic oxides are considered as amphoteric oxide. This question have been already appeared in your midterm paper. There is a, what do you mean by the amphoteric oxide? Give example. There is some metallic oxide which show the property of both acid as well as a base. Such metallic oxide are called as amphoteric oxide. Example, aluminium oxide and zinc oxide. Whereas in your exam, then we can ask here another one cross question. Show how the aluminium behave amphoterically. Show the aluminium behave amphoterically, or elaborate with the chemical equation the amphoteric nature of aluminium. So in such case, you have to elaborate these two equations. So let's move on to the next chemical property. How does the metals react with the oxygen in the different condition? Metals like potassium and the sodium, they react with the oxygen very vigorously and they catches the fire. Because of this reason, these two metals, they kept immersed in the kerosene to prevent their oxidation, that is to avoid their burning. Then we can ask here an application based question, why the sodium and the potassium they are kept stored under the kerosene. If magnesium is heated, it burns with the bright flame. Then we can ask here a cross question, an X metal, it is heated with the oxygen and it is produce a bright flame. Name the X metal and write the chemical equation. So for X metal will be the, which is the X metal, that is magnesium, and the equation we have to write how does the magnesium react with oxygen. Next, if the iron is heated, it glows brightly. So remember this, whatever the points I am quoting here, bright flame, and it is going to be burned up with a very bright dazzling flame. Whereas this question already have been came in final exam and even in the practice paper. If the copper is heated, it does not burn, but it forms a black coating of the copper oxide. So based on that, what the question have been came in your question paper, an X metal burned with the oxygen and it forms a black coating upon it. Name the X metal, write the chemical equation. So the X metal will be the copper, and then you have to write the chemical equation, how does it is going to react with the oxygen, and name the compound. If the copper react with oxygen and that black coating is nothing but what is that compound? It is a copper oxide. So remember, this question can also be appear as an application based question. Silver and the gold does not react with oxygen even under heat temperature. Remember this. Name the two metals which do not react with the oxygen at any condition, even at a very high temperature. There is silver, gold, even the platinum also the same. Some metals like magnesium, aluminium, zinc, lead, etc. forms an oxide layer over it which prevent the further oxidation. Hence, these metals are called as a self-protecting metals. You know that if the metals are kept exposed to the oxygen, they undergo the oxidation. But whereas these metals, such as magnesium, aluminium and zinc, they are forming the oxide layer themselves because they want to avoid the further oxidation. Hence, these metals are considered as self-protecting metals. Okay. Let's move on to the next chemical property of the metals, that is reaction with the water. Metals react with water to form metallic oxide or metal hydroxide, and along with that they liberate the hydrogen gas. For example, sodium react with water to form sodium hydroxide, which is basic in the nature, and along with that it is liberating which gas? Hydrogen gas. This is a point to be remembered. When any metal react with water, it liberates which gas? Hydrogen gas. In the same manner, potassium, calcium. Whereas about the calcium, you have to remember one application-based question they maybe can ask here. What is the question and what is the explanation? Calcium, if you drop it in the water, it will react vigorously, it will react, but this metal, it will not sink inside the water. It will be float upon the water surface itself. What is the reason? The reason it is, as we drop the calcium metal in the water, it forms the calcium hydroxide. Along with that, there is a liberation of hydrogen gas. That hydrogen gas, it is attaching to the surface of calcium metal, which is not making the calcium to be sink inside the water. In the same manner, aluminium and the iron also, they react with the water to form their corresponding oxide and they liberate the hydrogen gas. Some points to be remembered. How does the metals will be react with the water in the different condition? Sodium and the potassium react very violently with the cold water to form the sodium hydroxide and the hydrogen, and they will catch the fire. Previously I have given you the reason. Because of this reason, they will kept immersed in the kerosene. Calcium react less violently with the water to form calcium hydroxide and the water and do not catch the fire. And based on that, another one application based question I have quoted you. Why the calcium metal do not sink if you place it, if you react up with the water? Magnesium react only with hot water to form the magnesium hydroxide and the hydrogen, whereas metals like aluminium, iron and the zinc react only with the steam to form the metal oxide and the hydrogen gas. So whereas in your textbook, there is one discussion related to how does metals react with the steam. If the metals react with the steam, they liberate the hydrogen gas. But we have to summarize here an application-based question, that is how to detect the liberated gas is a hydrogen itself. So in your textbook there is an explanation based on that. We will use a test to identify the liberated gas is hydrogen, that is popping test. Nothing but I will explain you in the diagrammatic base. Metals like lead, copper, silver and gold, they do not react with the water at any condition. So remember, they maybe can ask a question, name the metals that do not react with the water at any condition. They are nothing but lead, copper, silver and gold. Reaction with the acids. Metals react with dilute acid to form salt and the hydrogen gas. Nothing but here we can expect a chemical reaction, nothing but it is a displacement reaction is going on. Magnesium react with dilute hydrochloric acid to form magnesium chloride and displace the hydrogen gas. In the same manner, zinc, aluminium, iron, they are all going to react with the dilute acid. They are forming the corresponding salt and displacing the hydrogen gas. Reactivity varies from metal to the metal. All the metal they do not, that is stand in the same condition that they are going to react with the acid. They will react with the acid in the different manner. Some of them they will react very fast, some of them they react very slow. So for the above metals, the decreasing order of the reactivity I have mentioned, even this one have been mentioned in your textbook too. Magnesium is more reactive than aluminium, than the zinc, and finally the iron. So it is one of the activity that we can ask in your choose the correct answer question. Copper, silver, and the gold, they do not react with dilute hydrochloric acid. Remember this point. Name the metals that do not react with the hydrochloric acid. That is copper, silver, and the gold. Hydrogen gas. As you know that if the metals react with the dilute hydrochloric acid, it is going to liberate which gas? Hydrogen gas. But whereas there is one exception is there, hydrogen gas is not evolved when the metals react with nitric acid. What is the reason they ask here as an application based question? Because it is a strong oxidizing agent. Which is a strong oxidizing agent? Nitric acid is a strong oxidizing agent. It oxides the hydrogen to produce the water and itself produces oxides of nitrogen. For example, a reaction I have quoted here, copper react with the nitric acid to form copper nitrate, displacing the hydrogen gas, and along with that it forming a nitrous oxide here. So nitric acid is a oxidizing agent, strong oxidizing agent. It self oxidizes to form oxides of nitrogen. Hence, there is no liberation of hydrogen gas when the metals react with nitric acid. So, diagrammatically, there is one explanation is there in your textbook too. You can able to see we have took some zinc granules in this test tube and we have added the dilute sulfuric acid. As you know that if the metals react with the dilute acid, they are going to liberate the hydrogen gas. And that hydrogen gas we are passing to a tuff which is containing a soap solution. As we pass the hydrogen gas to a tuff containing the soap solution, the bubbles which are present, they will rise up. And what the bubbles are being rising, we will ignite with a burning candle. As we ignite the bubbles with the burning candle, the bubbles will blast off with the popping sound. Then this is one of the positive tests to identify the liberated gas is which gas? Hydrogen gas. Remember this, they maybe can ask how you will identify the liberated gas is a hydrogen when the metals react with the dilute acid. Let's move on to the fourth property. How does the metals react with the metallic salt solution? This concept already we have been learned in the first chapter itself as a chemical reactions and their equation. One of the type of the chemical reaction as we have learned in the first chapter as displacement reaction. You can able to see we are using one of the metallic salt and we are using metallic salt solution. But here the main concept to be remember, it is a reactivity. Who will be the more reactive and who is less reactive? A more reactive metal always displaces the less reactive metal from its salt solution, and this reaction we consider as a displacement reaction. For example, magnesium, if it is react with the copper sulfate solution, it forms magnesium sulfate and the copper. In the same manner, zinc is react with the copper sulfate to form zinc sulfate and the copper. In these three reactions, if you observe, which is the most reactive and which is the less reactive? The most reactive it will be the metallic salt what we are treating with the metallic salt solution. So metallic salt solution, as you treat up here, the metallic salt is replacing the copper with that. That is here magnesium is more reactive than the copper. In the second equation, zinc is more reactive than the copper. In the third equation, iron is more reactive than the copper. Here, whereas we can expect here also one application based question. What is the question will be? They maybe can ask for 2 or 3 mark. A iron nail is dipped, immersed in a copper sulfate solution for 15 to 20 minutes. And you maybe have observed in your laboratory that is the copper sulfate solution is blue in color. The blue color solution, it is turned into the green color after 15 to 20 minutes. What is the reason? The reason it is, we have kept immersed the iron nail and that slowly after the 15 minutes if you observe, the iron nail it will be gradually turned up and it will appear as a copper metal. That is, we can able to observe the deposition of copper upon the iron nail. And what the blue color copper sulfate we have used, it is gradually turning into the slight green color solution. The green color solution is indicating that the solution now which is formed, it is a iron sulfate solution, and upon the iron what is has been deposited, the copper has been deposited here. Then it is a clear illustration that more reactive metal displaces a less reactive metal. Okay, so based on that, as I told you, to remember the displacement reaction we have to remember a concept of reactivity series. So first of all, what do you mean by the reactivity series? The arrangement of the metals in decreasing order of their reactivity is called as a reactivity series of the metal. As I told you from the beginning, some of the metals will react very vigorously, some of them will react very slow. So based on their order of reactivity, we have arranged from most reactive to the least reactive. But I have mentioned here one of the mnemonic concept to remember the reactivity series which has been mentioned in your textbook. There is a, first of all, we have the potassium, which is the most reactive, and at the end we have the gold, which is the least reactive. Whereas I think you maybe feel difficult to summarize this entire all the reactivity series. You can be able to observe here a mnemonic concept is here. Please, P stand for potassium, S stand for sodium. That is in the S I have mentioned as here stop. Ca, that is a calcium, calling. Magnesium, for that I have mentioned the mnemonic concept as a Me. A, aluminium, for that I have mentioned as a zinc. I have for that I have used the mnemonic word as a zebra. Iron, Fe is a symbol, but I have used the mnemonic concept as a I. Lead, like. Hydrogen, Her. C, that is a copper we have here, but I have used here as a call. Silver, in the place of the S I have used here smart. Gold, for in the place of that I have used as a gold. Whereas entire thing you can remember as a sentence, please stop calling me a zebra. Please stop calling me a zebra. In that you can able to remember up to here. Then from iron to gold you can remember a sentence as I like her call smart gold. So it is one of the mnemonic concept to remember a reactivity series of the metal. Based upon the reactivity series also, they maybe can ask some questions in their final exam. It is very important. So summarize this entire reactivity by using this mnemonic concept.